start that. So as a reminder, what you want to do is, first thing you'll do is go to the part of the circuit furthest away from the voltage source. So you're going to start over here on the right. But identify and name the nodes. You will then combine any resistors that are in parallel, and the idea is to come up with a single equivalent circuit. That's a series circuit. We'll solve the series circuit and then work backwards to the original circuit. So look at your notes from last class and see what you can do with this circuit.
If you're talking, you're still muted.
You're muted.
Okay, the voltage source is over here on the left. I'm going to start on the right. I see that I have R2 and R4 together. I make a node here and a node here. I'm going to go ahead and shade these in. First thing you want to do is identify any nodes in the circuit. We only have two. Remember, a node, you draw a circle or square around a group of wires, you'll cut that figure in 3 or more places. So I have a node here, it cuts it here, here, and here, so that's a node. Cuts it here, here, and here, so that's a node. I'm going to call the top one node A, the bottom node B. So you start like that, identify your nodes. Now, this circuit I can solve with just one combination. You can see I want to combine R2 and R4. So I can draw one diagram. If I give you a more complicated circuit, you might have to draw 2 or 3 pictures before you end up with the series circuit. In this case, there's just one thing you got to do to get down to the series circuit. So I'm already drawing my series circuit here. I'm going to transfer my information from the original circuit over to the series circuit. The value of R1 and R3, 3 ohms each. My nodes, and my node A is on the right side of R1 and the right side of R3. So in that picture over there, node A is somewhere in this circle, and B is in this circle. A is here, and B is there. They collapsed, they disappeared into those circles. And I see that I have resistances between A and B, R2 and R4, and I see that those are connected in parallel. So this resistor right here, I'm going to give that the name of R2 parallel R4. So I'm going to call this R2 parallel R4. If you take R2 parallel R4, I don't know if you can, well, let me put it up here. R2 parallel R4, I can use product over the sum rule. I have 12 times 4 over 12 plus 4. And I think when you do the math here, you'll get 3. That is R2 parallel R4. So this is 3. So I'm going to pause now. Hopefully you were able to get to that circuit over there on your own, but if not, I gave you a little help. So now what do? What happens next? So see if you can take that circuit over there, solve it. By solve it, I mean find all voltage drops and find the current to each resistor. Then you're going to transfer the information from the series circuit over to the original circuit, and then we'll solve the original circuit with that information. Again, I'm going to pause and give you a chance to, some of you might not have got that. So pick up at this point and then work your way back over to the original circuit. And we'll see how that works out for you.
While we have it in series as well,
If you have any questions, please ask. I'm not on the camera, but I am here in the room.
While we have it in series, is that when we look for our current as well?
I'm not sure if you can hear us.
Professor? Professor Singleton, can you hear us?
I think.
I think he's talking without being unmuted again.
Yeah, he is. I don't know why he can't hear anybody.
Everyone sounds
Yeah,
like a
I hear
robot.
nothing he's saying.
Anybody, if you have your ability to turn on your camera, maybe just try and wave him down. Maybe eventually he'll actually see the everybody's not on and someone else.
I think we still have a problem of connection.
How y'all doing?
Good, bro.
What's up, Michael?
I'm good. I think the teacher
How's
is
everybody doing with the
having trouble of connection. Maybe it
Still no
the
audio.
same problem was on Tuesday.
It says he left the session.
But everybody,
yeah, his it must just be really low or something.
Did anyone got 4.5 amps? Uh,
So I got 18 amps for the whole series, but then when you broke it out into the parallel, I got 1.5 amps for the 12 ohm resistor and 4.5 amps for the 4 ohm resistor.
I may have did that one wrong then.
Yeah. No, all I got was
I am
4.5.
guessing. This
three
is
and
just what I got. I have
because I
no
got 3 amps
confidence
and
in my
9
work right
amps for the parallel part, so I'm not sure.
Yeah, the
Wait,
one
so
day that like I was really looking forward to figuring out the series parallel circuits. It's really sad this is the day I decided to mess up.
wait, I thought there was only one answer. That is I'm wrong.
I went ahead and just tried to
In
solve the entire circuit.
That's what I did too. So I wasn't quite sure exactly because, yeah, certain parts have different amps, certain parts have different voltages, certain parts have same voltages.
I'm pretty sure that once it goes into the parallel part, that the 2 amp ratings should add up to 12, the original amp rating.
That would make more sense than the answer I got.
Because some of the people in chat are saying the same thing I did.
Okay, guys, I just realized you guys were sending me messages saying my mic is muted. Sorry about that. But hopefully you can see what I did. I gave you another circuit, and I want you to go ahead and solve it. I hope it wasn't, I don't know if it was muted when I went over the other circuit. I don't know if it was or not.
Yeah, it was muted for
80 messages.
since 9:15. We didn't see none of it.
Somebody sent me email. I'm just now seeing all of this.
The class is
You guys hear me
on
now?
now. Yeah, we can hear you.
I was muted since 9:20. So this whole lecture is basically done. We didn't see anything. Most of the class left. Okay. I don't know why you couldn't see anything. Yeah, some people texted me. The problem is when I have this Collaborate up, I don't see texts.
I
So I
can
get any
see,
of the texts, so I just
first
checked
I
this
can
out.
see what is front of me. I saw the second.
Wow.
I can see it. Can you hear me?
I couldn't hear any of you guys.
Oh shit.
Okay, I'm just reading your comments. Sorry about that. So what we may end up doing, somebody said we were muted. I was muted since 9:20. I'm gonna go back and watch the video, and I'll watch the video. I guess you guys can hear me now. I can't hear any of you for some reason. But I'll watch the video and see
We
where
can hear you.
I may have to redo this lecture on Monday. I don't know. It's a shame because we're kind of getting ahead of the game now, but it's okay. I did send you an email. Check your email, or you can check Blackboard. This problem right here is actually off the series parallel topic sheet. The other problems were just practice problems that I made up, but this is the actual series parallel practice sheet. It's one of two problems I was going to do in class, and it's actually your homework is here. Excuse me. Your homework is here. My mic is showing that it's picking up my audio, so I hope you guys can hear me now. I didn't have the projector on. I turned that on, so I don't know if, let's see. I don't know if you guys are hearing me or what. Oh, Thomas says you can hear me now. So I don't know. I don't think I had the projector the right way. Maybe that's what happened. Anyway, I'll review the video and we'll see. I hate to waste time, but I'll review the video, and then whatever we're missing here, I may have to go back and redo this. But in the meantime, this document, this is the first problem on this document. I wanted to go over this one and another one. We still got 10 minutes. We can probably do this one if you guys can hear me. But the homework for this is at the bottom of the page. Now, this homework is homework 6, but we haven't done any homework for, I don't think I've assigned anything for series and parallel. I just asked you to go to your book and do some practice problems. So I need to give you a formal homework for series and a formal homework for parallel. So we'll be doing this out of order. This is homework 6. I got to give you homework 5 and homework 4. So if you feel like you can attack this over the weekend, go ahead and try it. If not, that's fine. We'll do some more of this on Monday. We still have 10 minutes, so if you guys hear me, what I want you to do is to try to do this problem right here. And what I said was I wasn't going to give you any assistance, but since my microphone was muted, let's kind of walk through it together. So what you want to do here, draw the circuit. Go ahead and do that if you haven't done it. And then go ahead and identify your nodes. So while you're drawing the circuit, I'm gonna put my node information up here. So you should have this, and then draw the combined circuit, the equivalent circuit, which is the series circuit. So go ahead and get that. All right, so there you go. So there, you want to start at. You need to fill in the value of this resistor, move your node information over, and then solve that circuit. So we'll do this, and then we'll end with this one, and then on Monday I'll do the next one. And so this is figure 6.6 on the assignment on the sheet. Monday we'll do figure 6.7, and then 6.8, 6.9, 10, 11. That's homework for you. Again, I'm not gonna. You'll have plenty of time to do it because you really need to do some series and some parallel practice, and hopefully you've been practicing all along. But if you think you can, if you understand what I'm doing, you can probably go ahead and do those problems. But I'll leave it up to you. I won't collect it right away. I'll give you plenty of time. So see what you can do with that, and then we'll call it a day. And I'll go back and review the video and see how I can clean this mess up that I made on Monday. We'll figure it out. I'll figure it out. All right, so for combining these two, I want to double check myself on this, but I got a 990 ohm. Got 990. Using product over the sum. Let me just double check that. So my formula's there. I had 1.8 times 2.2 divided by 1.8 plus 2.2. I get 990 ohms. And node A would be here, and node B would be here. So, node information, I'll move that over, find these two resistors. And here's my equivalent circuit. Go ahead and solve that circuit. for voltage drops and current. And we'll compare what we got. That goes said 0.99, right? 0.99 is correct. So we're going to get the total resistance now. We got 120, 990, 390. Get 1,500 ohms for the total resistance. 1,500. And so now I want to find the current by taking the voltage of the total resistance. So get the current, I'm going to take the voltage over the total resistance, which was 1,500 ohms. I'm going to write it like that. So if I write it in K, that means my current's going to be in milliamps. 1 over K gives you milli. I got 30 divided by 1.5. Gives me 20 milliamps. This is 20 milliamps. So you're going to show that 20 milliamps in this circuit. You're going to show that 20 milliamps coming out of the voltage source in the original circuit. So go ahead and do that. I got my current arrow right here. 20 milliamps. I got my current arrow over here. Also 20 milliamps. I don't know if this green is actually showing up. Let me see if I got a better marker. I don't. So hopefully you can see this. I'll have to get some fresh markers for next class. I got 20 milliamps right here. Now what I can do is get all my voltage drops by just taking current times resistance. Now, since that current is in milli, what I'm going to do is I'm going to enter I'm not going to do it on the board, but on my calculator, I'm going to enter all my resistor values in K ohm. That way, the milli and the K will cancel. Hopefully you know what I mean. I've explained that several times in class. So I'm going to go 20 times 0.12 K. 20 times 0.99, 20 times 0.39, then I can just write whatever's on my calculator without having to do a lot of fussing around. So let's do that first one. That 20 times 0.12 K, 2.4 volts. Across this resistor, 2.4 volts. I got 20 times 0.39. $7.8. $7.8 volts. And then finally, I got 20 times 0.99. 19.8 volts. But this 19.8 volts goes from node A to node B. So over here, I'm going to draw it right smack dab in the middle, 19.8. Show it going from node A to node B. Node A to node B. So that no voltage is always across two or maybe even more resistors in parallel. They all get the same voltage. Now, just as a check, I want to make sure, I want to apply Kirchhoff's voltage law, add these up to make sure they add up to my total. So let's see if that actually happens. Just as a check, I got 2.4 volts, got 19.8 volts, I got 7.8 volts, and it adds up to 30. So I know I'm good. So that's a good check. Over here, you can do the same thing. You can add volts across this resistor, and that resistor. I get 30, or I can go this path right here. This voltage, volts across here, volts across there, I get 30. So that's showing you that KVL works in these little loops, but I'll say more about it next week. That's actually pretty important. So I'm running out of time. We got one more thing to do over here, and that's just to find the current in R2 and find it in R3. So just 19.8 volts over the resistor value of 1.8. That'll give you my current in milliamps. So go ahead and do that. 19.8 divided by 1.8 gives me 11 milliamps. So using my green, this is 11 milliamps. And I do the same thing with this one. I got 19.8 volts divided by 2.2. Okay, I get 9 milliamps in this resistor. Okay, so I noticed that I have 11 milliamps coming out of node A here, 9 milliamps coming out of node A here. I add 11 and 9, I get 20 going into node A. So that satisfies Kirchhoff's current law. I use that also as a check, and so my circuit is solved. And again, the only thing I can ask you for is power. In that case, you take the current times the voltage for each resistor, and you got the power dissipation. So I haven't heard anybody talk, so I don't know if you're able to talk to me, but Henry says, can you go back, please? So I don't know what that means. I'm not sure. So somebody open their mic. Are you guys able to talk or not?
I
Mike,
don't
or are you
think
able to talk to me? Try to talk to me.
Yes, Professor. Yeah,
I can't hear anything.
can you go back, please, for those two resistance? When you do the resistance 2 and 3, I didn't get you.
Okay, I can hear you. This was muted. Okay, Michael, ask your question again. Ask me again.
I say when you are giving the answer for resistance 2 and 3, I didn't get you. Can you go back, please?
You mean for this one? Is that what you mean? How did I get this one?
For 11 amps and 9.
Oh, for this?
Yes.
Oh, okay.
Yes, I didn't get you.
Okay, I understand. So let me put it right here. So current is voltage divided by resistance. So what I did, this 19.8 volts is across this resistor, and then 19.8 volts is across that resistor. So what I did to get this current, I took the voltage across this resistor divided by the value of it. So my voltage was 19.8 volts. And my resistor value is 1.8K. So if you do the math here, 19.8 volts or 1.8K, that should give you 11 milliamps. And then you do the same calculation for this resistor. You'll take your 19.8 volts divided by 2.2, okay, and that should give you 9 milliamps. So try that on your calculator and see if that works. Some people sending me their attendance. You guys are on it. I wish I was as together as you were. Michael, does that make sense? Do you get the numbers that I got here now?
Yes, please.
Anybody else have questions? It's a good question. Somebody came in here and readjusted everything. I had my mic muted, everything, the speakers were muted. I just came in thinking everything was working, and that just kind of messes me up. So a lesson that I learned is I got to make sure I get here and check everything. And normally I ask you guys if you can hear me, but I just assume that you guys can hear me, and I shouldn't assume anything. Any more questions over anything we've talked about?
I have a question.
Sure.
So you know how you calculated the resistance for node A and node B?
Yep.
Why didn't you use the parallel equation for resistance? Why did you use the other one?
You can use either one. Either one should give you the same answer. So I could have said, I'm going to erase this. I could have used the 1 over R rule. So I could have said, I got 1 over 1.8 plus 1 over 2.2. I can do that. And then I can use my inverse X key, and I can do it that way. I chose to use the product over the sum rule. So I said 1.8 times 2.2 over 1.8 plus 2.2. I use that one. You have a choice though. You can use either one. It doesn't matter. It should give you the same answer. To me, sometimes it's more convenient to write it this way. Usually I use this one. I can easily do the numbers in my head. Since I had a calculator, I usually don't have this. I depend on you guys to give me the answer. But in the interest of time, I just took my calculator out and I just wrote it that way. But what you want to try, I think that's Shelly. Shelly, try it this way and then try it the other way and make sure you get the same answer. You'll see that you'll get the same answer. So at that point, it's just a matter of personal preference, whichever one you want to use. There's no particular reason why I chose this one over that one. I just think it was easier to write. But either one should get you the correct answer. Any more questions? I think I lost a lot of the class. I think we started with 21 or 24 people. And then because of my microphone and all the technical difficulties we had, it dropped down to, at one point it dropped down to 9, and some other people must have logged back in. We got 12. So, can you please send me the link? Yeah, the link to today's lecture it should be on Blackboard. Did I not put it on Blackboard? The link to today's lecture should be.
Professor, so I have section 2 and it doesn't show up on mine.
Yeah, but if you go to your Blackboard. Oh, wait. I see what you're saying.
Yeah, I got section 2.
Yeah. So you know, guys, I think what I'm going to do, I'm going to, man, that's a problem. I'll send you the link out, but what I'm going to do is I'll send that, but I'm going to send you another lecture too, but it was one I did last semester, so the problems may be different, but the content, the concepts are the same. And I'll send that out to you. I'll send that out to you, and then I'll send you on my YouTube channel. I'll find out where this stuff is, and you guys can look at this. I'm going to view that video. I'm going to view that video over the weekend, and I'm going to come back and clean this up. I want to come back and first I need to know what didn't you guys see, and then after that I'll come in and I'm going to do some more of this. So we'll get caught up. But yeah, I'll send that video to you, and I'll send you another link. You'll have. No problem. Yeah, Thomas wants the same thing, so I'll send you guys the links. All right. Well, any more questions? If not, I'm going to sign off and start my weekend, and then I got a lot of stuff to do with these videos, homeworks, and all of that.
Yeah, Professor, I saw here on this sheet, you say you already do the first, second, and on Wednesday they were going to do 2, 3. You say that the 4 one is our homework, 4, 5, and 6.
Do you have the sheet that I emailed you?
Yes, I printed it already.
Okay, at the bottom of the sheet, it says for homework, do problems 8, 9, 10, and 11. If you have that sheet, look at the bottom of the sheet.
Okay, I saw it.
But you don't, like I said, I'm not gonna. It'll be a while before I collect it because I want to make sure you guys can do this. I
Okay.
still have to do homework 5 and homework 4. So yeah, if you understand it, I think that's Michael. If you understand it, go ahead and by all means go ahead and try to do it. But we're gonna go over some more stuff because I want to make sure everybody that stuff like this is all worked out. Okay, so yeah, try it if you want to, but we got a lot more practice to do with this stuff. Any more questions, guys?
Professor,
Yes.
how do we solve for the voltage across the nodes?
How do we get the voltage? Do you see how we got this voltage right here?
Like for no, not 19.8.
Say it again. You said
Not no for that part.
you don't know how we got this?
Yeah.
Okay. All right. So do you understand how I got the current?
Yeah.
Okay. How did I get the current? I took the total voltage divided by the total resistance. Now to get each of these voltage drops, all you do is take the current times the resistance. So to get this one, I took the current, which is 20 milliamps, times the resistance, which is 0.12 k ohm. And the reason I wrote it like that is when this is in milli, you want the resistor to be in k ohm. You don't have to do that. You can write this. If you write that as a decimal number, then you can multiply that times 120. But I like to, it's easier for me to do it that way. I did this, 20 milliamps times 0.12 k, and that gave me the 2.4 volts. And then you do the same thing for this one. It's going to be 20 milliamps times 0.99 k, and that should give you the 19.8. And then 20 milliamps times 0.39 k, and that should give you the 7.8. So
I understand how we got 990, but it says 1.8 k ohms on the series parallel circuit.
this,
Isn't that what resistor 2 is? 1.8 k ohms.
yeah, it is.
So why is it 990? Like on the
Yeah, so what we do, we take these two and combine them into one.
Okay.
You follow that?
Yeah.
So they're in parallel, so if you combine those into one, how do you combine parallel resistors? If you have two resistors in parallel, how do you get the total resistance? What do? You do this. You take the product over the sum. You do R1 times R2 over R1, right? Remember that?
Mm-hmm.
Okay, so if you do that, you do 1.8
Oh.
times
Okay.
2.2. See it? You see it now?
Yeah.
If you do that, you should get this. Try that on your calculator to make sure you get that 990. You might have to put this in parentheses to get it to work on your calculator, but you should get 990.
Yeah, I got it.
Okay. Does that answer your question? Do you understand now?
So then, you like? I know that the total current is 20 milliamps. So how do you get 11 and 9 through each circuit?
Okay, well, once you figure out that you got 19.8 volts across between A and B, and over here, you know you got 19.8 volts between A and B, right?
Yeah.
Well, what's connected between A and B? R2 is connected between A and B, so that means it has 19.8 volts across it. R3 is connected between A and B, so it has 19.8 volts across it. Since I know the voltage across the resistor, what do I need to find current? I just need the voltage across the resistor and the resistance. So what we did there, we took 19.8 volts divided by the 1.8K, and that gave you 11 milliamps. And then we do the same thing over here. We take the 19.8 volts divided by 2.2K, and that should give you the 9 milliamps. So try that, make sure it works out in your calculator. You just use Ohm's law. Current, resistance. Did it work out?
Yeah, that makes a lot more sense now. It's just a lot.
I know it is, right. Yeah, I'm glad you asked the question. I hate when students don't understand something they don't ask, but yeah, you'll get it. Just got to keep practicing.
And so we have homework problems for series.
I'm going to give you some over the weekend. I'll give you. I kind of jumped the gun here. I gave you a series parallel, but I'll give you some for series. I'll give you some for parallel. But in the meantime, take your book, go into, I think series is chapter 5. I think go into chapter 5 and look at the example problems they have in the chapter. Look at the homework problems at the end, and you can actually practice that. Even if I don't give you problems, you can practice it. So practice that, and it's just the homework is something you're going to turn into me, but you should be able to practice on your own. But yes, I am going to give you problems on that, on series and parallel. Okay, anybody else? So I got Thomas' request for you. I think he might be gone. He tried to compare our answers in the chat. Okay. All right. All right, guys, I'm going to send you out some links to look at. We'll get all this straight. Don't worry too much about it. I'll review the video, figure out where I went wrong, what you guys didn't hear, and I'll take care of it on Monday. Have a great weekend. If you need me, just send me a text, and I will see you guys on Monday.